Welcome children, I think you all are eagerly waiting for today's digital class. Children, in the earlier classes we have discussed about the trigonometry, is it right? In the trigonometry we have discussed about the trigonometric ratios based on the right triangles, right, and we have discussed about the trigonometric ratios on some special angles like 0 degrees, 30 degrees, like, is not it? Now, even we have discussed about the trigonometric identities like sin square theta plus cos square theta is equal to 1, right. Now, where do these trigonometric ratios are useful? Where do we apply these trigonometric concepts? Let us discuss applications of trigonometry. So, today's topic is applications of trigonometry. Applications of trigonometry, recap, trigonometric ratios of some special angles. We are going to discuss ratios 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. First ratio is sin theta, next ratio is cos theta, then we have the tan theta we have, is not it. You are able to see the table which is going to give the values of some special angles, is it right. Now, not only this, we have 3 more trigonometric ratios, but how these ratios are being arrived, let us recap of them. Like, see, we have the sin theta is equal to opposite side by hypotenuse, cos theta is equal to adjacent side by hypotenuse, tan theta is equal to opposite side by adjacent side. So, these 3 trigonometric ratios are going to play a major role in the applications of trigonometry. We have a question here. How do you measure the height of a boy? Here is a boy. How do you measure? Yeah, this is a measuring tape. So, you will be putting it vertically and you will be able to measure the height of this particular child, is that right? Here the child is standing on the level ground. From the level ground we are going to measure the height of this particular child. Let me draw a line at the top of his head. So, here it is going to give us that the measurement of the particular boy is around 5 feet, right. So, this is fine. How do you measure the height of a pet? Let me say dog. Yes, it is easier for us to measure the height of the dog like using the measuring tape, is not right. This is a boundary wall. So, how do you measure the height of this boundary wall? I think we can here also we can use the same type of measuring tape. This is Charminar, this is the Eiffel Towers. Can you use the same measuring tape to measure the height of these particular structures? Now, we have some more. Let me see, this is the pillar we have and the buildings. Can you use the same tape to measure the height of these buildings? So, depending upon the situations we may use the different tapes to measure the heights of the structures, is not it. But sometimes it becomes very difficult for us to use the measuring tapes to measure the height of the particular what you can structure or anything building or any other thing. Let me take about the mountain here. Are you able to see a mountain? Can you measure the height of this mountain? How do you measure? So, here is a child who is thinking how to measure the height of this particular mountain. Do you use the same measuring tape? Vertically straight, let us think this is the line joining the eye and the tip of the mountain. So, this particular line we call it as the line of vision. What do you call this? Is line of vision. That means, from where you are observing the top of that particular mountain, you will be calling it as the line of vision. Now, in general we have a horizontal line of vision. That means, when a person stands normally, you can say that his vision will be straight. So, that is called as horizontal. Now, let me think the vertical measurement of that particular mountain be something like height we call. Suppose if I say that is height, you are able to see there are 3 lines, one is white, other one is yellow, the height is in red color. So, is it looking like a triangle or not? If it is looking like a triangle, you are able to see that you are going to find a 90 degrees angle, that is a right angle between the height and the horizontal. Therefore, the triangle formed by the three lines, that is horizontal line, height, or you can say vertical line, and with the line of vision you are going to see there is a right triangle is being formed. Now, what do you call the angle between the line of vision and the horizontal line? We call it as angle of elevation, because the reason is that is the child is lifting his head up and trying to observe the top of the mountain, is it right? So, when you are lifting your head, that means when the vision is being lifted up, rising, you will be calling it as the angle of elevation. Are you clear, children? Now, let us think, there is a building, there is a person who is standing on this building and trying to watch a person who is on the ground. Now, we neglect the height of the person, this is called as line of vision, but the same person who is standing on the building, if he is watching straight, then the line of vision for that particular person is like this. This is called horizontal line of vision, we call, simply we call horizontal line also. So, now what do you call the angle between this horizontal line of vision and actual line of vision when he is watching the child the down? See, what do you call this is? This is called angle of depression. What is the height at which the person is on the building? Let me think, this is the height at which the person is standing on the building. Is it parallel to the height at the same point? Yeah, please see, both are parallel. That means what is happening here, you are able to find a triangle is being formed here, isn't it? Please see, and here the line, that is horizontal line of vision, and the vertical line are perpendicular to each other. So, you are going to say 90 degrees, and hence it forms a triangle, right triangle. Are able to see? So, we can say that horizontal line of vision is always parallel to the ground. Here also you can say that both the height as well as the horizontal both are perpendicular to each other. So, we call it as 90 degrees. See here, what do you call this is? Angle theta. Why we call this is angle theta? Already we have said one more angle theta, but why we are saying this is also angle theta? Here you will be able to see that when the horizontal line of vision and the ground are parallel to each other, these two angles are alternate to each other. So, I will be calling this one as alternate angle of depression. Are you clear, children? Thus, this is also going to form a right triangle again. Now, there is a watchtower. A child is watching the tower from somewhere far from it. Let me now, he is watching it, same again line of vision. What do you call this is horizontal line, or we can say call now here base. The angle between the line of vision and the horizontal line is how much here? Theta. Now, what is this? Altitude. So, this is the altitude which is going to give you our height of the particular, what do you call that is watchtower, is it right? The height of the watchtower we can say here, and now both are 90 degrees to each other. So, this is again going to form a right triangle, isn't it? Now, there is an aeroplane, same boy who is going to observe the aeroplane from ground. This is called line of vision. His the horizontal line of vision is called as base. Now, this is the vertical height, or you can say altitude at which the particular aeroplane is flying. Same procedure. What do you call that is? Right angle. Now, this is angle of vision. Since the child is looking up, what do you call this? This is called also angle of elevation. Suppose instead of this, suppose a person is somewhere on the height or somewhere at some altitude and is supposed to watch a children or somebody else the down. How he watches? Let us discuss about. Let us think this is a cable, right, on which a person who is traveling or moving in the. So, a person who is traveling in the cabin of ropeway, he is trying to observe a child who is standing on the ground and another child who is running. Let us think. We think that both are on the same horizontal line. Let me call this base. Now, this person, the height of the person is, this is red line is going to give us the height of the person, or you can say altitude you can say. He is watching the child who is on the right side to you this is called angle of vision for him, and the another one is you are able to see the person is watching this boy who is standing on the right side of him, isn't it. Here the blue line is going to give you the picture of line of vision, and suppose he is trying to watch a child who is running, then the deep blue color line is going to give us the line of vision of the person who is in the what you call cabin, is it right. Now let us think, there is a horizontal line of vision. Now the angle made by the horizontal line with the line of vision you can see here. So we have here two angles. So I will be calling here, instead of theta, I will call this angle as alpha, and now you will be calling this one as angle of depression alpha. One more angle is there, I will be calling it as angle beta, is that right. So this is also angle of depression. When you observe that, you are going to find the horizontal line as well as the base which are able to observe, both are parallel to each other. Therefore, what you can say here, again you are going to find the alternate angles. Now altitude and base are perpendicular, so I am writing here 90 degrees. This is alternate angle of the alpha, both are same. One more, that is this angle is also alternate to the beta. So both are equal. Let us discuss. A tower on the ground from a point which is 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is 45 degrees. What is the height of the tower? When you want to discuss it, what we have to do? Are you able to see, this is a Qutub Minar, isn't it? Are you clear, children? Now here is a child who is going to observe it. So the height of the tower is, let me think, it is a vertical line, I will be calling it as AB, and I will think that height of the Qutub Minar or that particular tower is H. Now this is called line of vision. What about this? Horizontal line, as we have discussed. So this is called as the distance between the observer and the foot of the tower. Here the point B we call it as the foot of the tower. For anything, whenever you have the building or anything, the line which is touching the horizontal, the down, you will be calling it as the foot of that particular building or tower or person, whatever it is, isn't it. So here B is called as the foot of the tower, and the point O is said to be the point of observation. So you are able to see a clear triangle here, but again here he has given us the, what he gave, he says that from a point which is 15 meters away from the foot of the tower. That means the distance between the foot of the tower and the observer is 15 meters. So I wrote here OB is how much? 15 meters. Are you clear, children? Now I have to discuss about the angle. What is this angle? 90 degrees, right? Therefore, triangle AOB is going to become a right triangle and right angle at B, right? Now what is the angle of elevation here? How much it is? 45 degrees. That means the angle of elevation here it is 45 degrees. Are you clear? So please see, is it a perfect right triangle or not? Now if we skip these pictures, we will be able to see only the triangle and their parts of it, right? Please see. So now what I have to do here? I have to start solving this one. Now you are able to see there is an angle and a side which is opposite to it. You are able to see this is an angle and this is an AB which is opposite to the angle. I will be calling it as opposite side, as we have discussed in the trigonometry part 1, isn't it. Now I will be discussing about the adjacent side, which is the side to the angle, and one more you will be finding out the hypotenuse, isn't it. In a right triangle, the side which is opposite to 90 degrees we always call as hypotenuse. By using these concepts, let us discuss. So the horizontal distance, that is adjacent side, OB is equal to how much here? 15 meters. So in that cases we do not know the height of the tower. So I will be calling, let the height of the tower, that is opposite side AB, is equal to some h or h meters, I can say. Now, what is the angle here? The angle of elevation theta is equal to how much? 45 degrees. So, now you are going to find the opposite side, you know the adjacent side. So, when you are talking about the opposite side and adjacent side, what ratio we use? So, earlier we have discussed sine, cos, tan. So, in this, so the concept where we use opposite and adjacent side is tan, is not it? So, we are going to use the concept of ratio of tan, is not it? Please see. So, I will take in triangle AOB, tan theta is equal to opposite side by adjacent side. This ratio I am going to adopt here, because here I need only opposite side and I know adjacent side. That is the reason I am using tan theta, because I do not require any hypotenuse, because hypotenuse is not coming into the picture. That is the reason I am taking tan theta. Now, theta is how much here? 45 degrees. So, I will be taking tan 45 degrees. What is opposite side here? AB. What is adjacent side here? OB. So, AB by OB. What is the length of AB? It is h. What is the length of OB? 15. So, what is the measure of tan 45 degrees? It is 1, is not right? So, tan 45 is equal to 1. So, I will be writing here on the left hand side 1 is equal to h by 15. So, if I go for the cross multiplication, 1 into 15 is equal to h, or h is equal to 15. That means, the height of the tower is 15 meters. Are you clear, children? So, with this we are able to find out the height of the tower without using any kind of measuring tape or any other device, is not it? Now, let us discuss one more sum here, please see. Suppose you are shooting an arrow from the top of a building at an height of 6 meters to a target on the ground at an angle of depression of 60 degrees. What is the distance between you and the target? Let us think, this is a target and he is the person who is going to shoot the target, is not it? You are able to see the bow and arrow in his hands, is not it? The same person, if he is, as per the question, if he is standing or he is on the building, but where is the building here? So, let us see here, this is the building on which he is going to stand and he is going to hit the target which is down. So, let him climb on that building. After climbing the building, he is going to shoot the target which is down. How he shoots? Let us think, this is the line of arrow which is going to reach. Let us think there is no any kind of bending or anything of deviation. Let us think it is the straight line, isn't it? So, in that cases, this is called as the line of shooting, you can say, as we have discussed in the earlier cases like line of vision. Now, what is the height at which the person is standing? Oh, this is the going to give us the angle of depression, because at what angle he is bending the arrow to shoot the target. So, horizontal and as well as the line of his shooting arrow, the angle between them is how much here? 60 degrees. Are you clear? Now, you are able to see the vertical line as well as horizontal line, which are going to give us the height as well as the horizontal distance or the distance from the foot of the building to the target. Both are directed to each other, that means the angle between them is how much? 90 degrees. Now, what is the height at which the person is standing? It is 6 meters, right? Now, what he is asking? He is asking us to find the distance from the shooter to the target, isn't it? This is going to become 60 degrees. This is a right triangle, please see. Now, let me give the vertices O, T and P. P is the foot of the perpendicular, T is the point of target, O is the point from where the person is going to shoot. That means, you can say point of observation also you can say here. So, now please see the height of the building, that is opposite side, OP is equal to 6 meters. Let the distance between the shooter and the target be x, let me think, isn't it? Now, the angle of depression is how much? 60 degrees. So, when you are saying let the distance between the shooter and the target, means that is nothing but the OT. OT is nothing but hypotenuse, and you know the height. So, opposite by hypotenuse, what ratio it is? It is nothing but sine, is it right? So, now I will be taking the sin theta is equal to opposite by hypotenuse. Theta is equal to how much here? 60 degrees. Sin 60 is equal to OP by OT. Sin 60 is equal to root 3 by 2. Now, root 3 by 2 is equal to 6 by OT. Is that right? Now, OT is equal to 6 into 2 by root 3, which is equal to how much here? 12 by root 3. So, I am going to rationalize and denominator. So, in the numerator I will be getting here 12 root 3 by 3, because root 3 into root 3 is how much? 3. So, you can cancel this 12 by 3. So, what is the answer you are going to get here? 4 root 3. That means, the distance between the shooter and the target is 4 root 3 meters. Now, we have one more question for you. Please see the statue of Mahatma Gandhi, is it right? And now, let us first discuss about the question. A statue stands on the top of a 2-meter tall pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees. And from the same point, from here, horizontal line, how much it is? This is the vertical line, which is going to measure the total height of this particular statue from the ground, you can say. Both are 90 degrees to each other. Are you clear? And now, you are watching the top of the statue, first line of vision, because here you are going to observe 2 points. So, this is called first point, and what is the angle here? It is 60 degrees. Is it right? Now, we are going to observe the height of the pedestal up to here. This is another line of vision. What is the angle? It is here. Please see, it is 45 degrees. That means, here you are going to get 2 angles of elevation. What is the height of the pedestal? It is 2 meters. I have to remove all the remaining structures. Now, please see, this is a right triangle which is being formed for the first line of vision to the complete statue, isn't it? Here you are able to see the. So, these are the 2 parts which we have to discuss. Now, here we have one more triangle. This is smaller triangle, right angle triangle. So, now I have to give the names to the points, or you can say vertices of those 2 triangles. Now, let me say here the point of observation I will call it as O, and this point I will be calling it as a foot of the statue, complete statue, that is, let me say A, and this is the top of the statue B, and this I will be calling it as the point at which that is called as the top of the pedestal. I will be calling this point as the C. So, that you can say here AB, AC, BC. So, here BC is the height of the statue, and whereas the AC is the height of the pedestal, that is already given as 2 meters, right. So, I have to find out BC. So, here let me say the height of the statue is h, let the horizontal distance x, the height of the pedestal is equal to 2 meters, the angle of elevation of the top of the statue, that is angle AOB, how much? It is 60 degrees here, yellow color, is that right? The angle of elevation of the top of the pedestal, angle AOC, is equal to 45 degrees. Now, we are going to use the 2 triangles. So, before going to solve the bigger triangle, let us take the smaller triangle, that is AOC, and try to solve it first, and then we will go to the. But here, what is the complete length of AB? OA is equal to x, AC 2 meters, CB statue part, that is h. Now, AB, the complete height of the statue including the pedestal, that is called how much here? 2 plus h. Now, angle AOB 60 degrees, angle AOC how much here? 45 degrees. In right triangle AOC, now here I know the height, I do not know the base, but I know the angle of elevation. So, this is opposite and this is adjacent. Tan 45 degrees is equal to AC by OA or AO. AC is how much? 2, OA x, but tan 45 is how much? Again 1, right. So, 1 is equal to 2 by x, therefore, x is equal to how much here? 2 meters. In right triangle AOB, B. So, tan theta is equal to opposite by adjacent side. So, here theta is how much? 60 degrees. So, tan 60 degrees is equal to AB by AO. Tan 60 is how much here? Root 3. So, root 3 is equal to AB is how much? 2 plus h by AO is how much? X, but x is equal to how much here? 2. So, root 3 is equal to 2 plus h by 2. So, I am going to multiply root 3 into 2, which is going to get the 2 plus h. When you multiply root 3 into 2, it is going to become 2 root 3. So, now I am going to shuffle them. So, 2 plus h is equal to 2 root 3, h is equal to 2 root 3 minus 2, but the root 3 value is how much? 1.732 approximately. Therefore, 2 times the root 3, that is 2 into root 3 is equal to 2 into 1.732, which is 3.464. So, h is equal to 3.464 minus 2, which is equal to how much here? 1.464. Are you clear, children? The height of the statue is 1.464 meters, right? Children, I hope you have understood the implications of the trigonometric ratios, isn't it? Or different examples based on the trigonometric ratios, how these trigonometric ratios are helpful for us in finding out the heights and the distances, like, isn't it? Now, here is an assignment for you, please children. So, the assignment is, first question for you: a string of kite is 100 meters long and it makes an angle of 60 degrees with the horizontal. Find the height of the kite assuming that there is no slack in the string. It is perfectly straight line, you have to think. The question number 2: a man standing on a tower observes the stone on the ground at an angle of depression of 45 degrees, which is 25 meters away from the foot of the tower. Find the height of the tower. The question number 3: the angle of elevation of a ladder leaning against a wall is 60 degrees and the foot of the ladder is 9.5 meters away from the wall. Find the length of the ladder. From the top of a building 60 meters high, the angles of depression of the top and the bottom of a pole are observed to be 30 degrees and 60 degrees. Find the height of the pole. Question number 5: a vertically straight tree which is 15 meters high is broken by the wind in such a way that its top just touches the ground and makes an angle of 60 degrees with the ground. At what height from the ground did the tree break? Children, this is an assignment for you. I hope you will be able to solve all the assignment questions without any hesitation. If you have any doubts in this, I hope you will be able to clarify with your subject teachers, and I expect you will be trying to solve still more questions from your textbook. So, I hope you will be able to do well. That is all for today. Thank you. Have a nice day.